In today's video notes, we're going to be discussing the last real major concept of stoichiometry, which is limiting and excess reactants, and then in relationship to that, percent yield, which we won't get into in today's video. We're going to focus mainly on limiting and excess reactants. But when you think about limiting reactants, I want you to picture building a bunch of sandwiches. You're making a whole bunch of bologna sandwiches, and you have to make every single sandwich the same way every time. So you need 2 pieces of bread per sandwich, 1 piece of bologna per sandwich. Limiting reactants in chemical reactions are like if you have 10 slices of bread and only 4 pieces of bologna. You're going to be limited as to how many sandwiches you can make by the bologna. You're only going to be able to make 4 sandwiches, even though you have enough bread to make 5 sandwiches. So that's really what limiting reactants are. Limiting reactants are the reactants that limit the amount of product that you can create. In a limiting reactant problem, the limiting reactant is going to be whichever reactant is completely used up. You're going to use all of that reactant in the chemical reaction. So if you think about our bologna sandwiches, the slices of bologna, that's our limiting reactant. We're going to completely use all 4 slices of bologna, and we're going to have some bread left over, and that's going to be our excess reactant. So the limiting reactant, again, is the reactant that is completely used up in the reaction. And then the excess reactant is the reactant that is left over at the end of the reaction. So we think about our bologna sandwiches. The bologna is the limiting reactant. It's going to limit the amount of sandwiches we can make. We can only make 4 sandwiches with 4 slices of bologna. And we're going to have 2 slices of bread left over. Technically, we have enough bread to make 5 sandwiches, but the last sandwich would just be an air sandwich. So the excess reactant is the bread, and it's the reactant or reactants that are left over at the end of the reaction. I often shorten limiting reactant and excess reactant to LR and ER, so that's my shorthand. But the limiting reactant determines how much product you can make in a chemical reaction. So in most reactions with 2 or more reactants, one of those reactants is going to be limiting. One of them is going to run out before the other reactants, and whichever reactant that is, that one is going to determine how much product can be created, how much product can be made. So if you think about a campfire, it's a combustion reaction, and the 2 reactants are the wood, the fuel, and oxygen in the air. And by far, the wood is the limiting reactant. It's going to run out before the oxygen in the air runs out. And so that's going to determine how much fire you can make. That's all a limiting reactant is. It's the reactant that limits the amount of products you can produce. If you're looking at 2 different reactants, like let's say I tell you 2 different masses of 2 reactants, like you have 10 grams of hydrogen and 20 grams of oxygen. Which one is your limiting reactant? How much water can you make? The limiting reactant is going to be whichever reactant produces less product than the excess reactant. So usually if you compare the 2 using stoichiometry, if you do mass to mass or mole to mass conversions, and you figure out which one is going to produce less product, that's going to be the limiting reactant. So let's do an example. How many grams of carbon monoxide, or CO, will form when 7 grams of silicon dioxide and 50 grams of carbon react. And I will go ahead and give you the balanced chemical equation, which you will need if we're going to be doing stoichiometry. You have to have a balanced chemical equation. Okay, so the way that this problem differs from problems that we've done in the past is now, instead of just giving you the mass of one of the reactants or one of the products, I'm giving you the mass of 2 reactants. And you have to figure out which one is going to produce less product. So you're actually going to have to do 2 calculations here. We're going to start with each of those 2 reactants, and we're going to figure out which one produces less product. So if we start with 7 grams of silicon dioxide, we're going to figure out first how many grams of carbon monoxide 7 grams of silicon dioxide will form. So we're going to do a mass-to-mass conversion. So we're going to determine the limiting reactant by figuring out which of these 2 reactants is going to produce less product. And you might just think, oh, well, there's 7 grams of one reactant, there's 50 grams of the other. Whichever one is 7 grams, that's the one that must be the limiting reactant. But that's not always the case, because you also have to take molar mass into account. Mass ratios are not always the same as mole ratios. And that's an important concept. So let's start with 7 grams of silicon dioxide. And we're first going to convert that to moles of silicon dioxide so that we can use mole ratios. So divide by the molar mass of silicon dioxide. And then use the balanced equation to set up a mole ratio from silicon dioxide to carbon monoxide. So for 2 moles of carbon monoxide, there is 1 mole of silicon dioxide. Again, I just got that from the balanced equation. And then finally, I'm going to determine how many grams of carbon monoxide will be formed. So 1 mole of carbon monoxide, the molar mass of carbon monoxide is 28.01 grams. And if you plug that into your calculator, 7 grams divided by the molar mass of silicon dioxide times 2 times 28.01. And we get the mass of carbon monoxide that 7 grams of silicon dioxide would form. So now let's see how much carbon monoxide 50 grams of carbon would form. And if it's more than what 7 grams of silicon dioxide would form. If it's more, if it's going to be greater, then that's going to be our excess reactant, and if it's less than, that's going to be our limiting reactant. So we're going to do a very, very similar setup here, just instead of silicon dioxide, we're going to focus on carbon. So we're going to use the mole ratio for carbon, the molar mass of carbon. Plug that into the calculator. And you get 77.7 grams of carbon monoxide, which is much larger than 6-ish grams of carbon monoxide. So we know that silicon dioxide is our limiting reactant because it produces less product. And we also know that 6.55 grams of carbon monoxide, that is the maximum amount of carbon monoxide that we're going to be able to create. Remember, think bologna and sandwiches, or bologna and bread. Even if we have enough bread for 5 sandwiches, we can only make 4 because we only have 4 slices of bologna. So even though we have enough, 6.53, I can't even read my own handwriting, 6.53 grams of carbon monoxide is the max we're going to be able to create. Even though we have enough carbon to create 70-ish grams of carbon monoxide, we only have enough silicon dioxide to create 6.53 grams of carbon monoxide, so that is the max we're going to be able to create. So here's a challenge problem for you to try on your own. I'd like you to see if you can figure out, given these numbers, how much of our excess reactant, that is, how much carbon, is going to be left over at the end of this reaction.